I was doing a webinar and a viewer had a very interesting question and I didn't get a chance to fully answer it, so I would like to do so now. This is a question about how do we make gear racks in Alibre, especially given that in the script we can create a involute spur gear quickly and easily. So I can run into my mechanical, and I have a gear generator by diametral pitch here. So we can run that, and I can maybe make a very large diametral pitch of 1. And we'll say OK. So I created this pretty large gear, and maybe I'm going to re-extrude it to a distance of 5, just so it's a little bit more proportional looking. And with this very large gear, I want to make a flat rack for it. How do I do that? Well, first off, I'll save this as a gear. Now once I have this gear saved that I know I'm going to use, I also want to make a file for my rack. And I'll base it off of the gear that I'm going to have run in the rack. So I'll do another save as. And for this, let's go ahead and use one of the teeth. Now, the spacing between gear racks and gears is pretty straightforward. We use the diametral pitch of the gear, which is to say, how many teeth per inch am I using? And whatever that answer is the spacing that we have between our gear teeth. So I have 1 tooth per inch, which is a pretty large gear, and I want to make a rack out of it. Well, I'll go ahead and delete this extrusion here, and I could just run into this profile. Now I like that I can edit my sketch and grab some of my tooth profiles first. I'll chain select everything, I'll hold shift and deselect just this component of my tooth right there and delete everything else, right? So I've got this tooth isolated, and I'll make sure that I dimension this in a way that this doesn't walk around on me anymore. So I give this a distance from point to point, a radius from here to here, do a distance between those points. I'll probably give this a solid line across here, and I can make a line from here to here. And we'll grab an equal and make sure that we have an equal distance between these lines. And now, yes, I should be able to just move this tooth profile along and have it be exactly what I need. So we'll grab a coincident and put this point right on the origin, just like that. And we'll go with horizontal. And now I can extrude. So the question is, how do I get these teeth to be a rack? Linear pattern, of course. We're going to pattern it down this axis here. And then what's our spacing? Well, we have a diametral pitch of 1. And so I'm going to say pi divided by 1, right? Because when we go from a circular diametral pitch to a straight rack, we just take pi divided by whatever that pitch is. And then I can up the instances here, and we'll say OK, right? So we got a 12-tooth rack, and I'll finish this off by adding a sketch. And we'll grab a coincident and make sure that we can be coincident along with on these points here. There we go. And then over here I'll project with maintained association. We'll do a coincident on that little point there. Give this just a simple dimension of 1. We can extrude that just to make a more complete looking rack. That's a bit more realistic, right? So I've got my rack. We'll save that, and I have my gear. Let's make an assembly and put them together. So here in a new assembly, I'm inserting my gear and rack, and I'll in fact edit this here and add a little hole in the gear just to make things look a little bit more realistic, right? Most gears have holes in them, and it can help our constraints a little bit. So we're gonna to depth through all. Okay. What I'll do is I'm going to go back to my assembly. We'll add a constraint so that this gear is constrained around this axis. I'll constrain this face to this plane, and I'm left with a gear that can just rotate, right? So I'll take this face and line it up with my gear. Now there's a certain distance that you'll want to have from, say, the center of this gear with the plane running through it to the part of the rack here. I'm just going to shorthand this and put it right about there. And let's get this rack mate going. So first we're going to select on Gear 1 geometry. We're going to select this little edge here of this rack. And then Gear 2 geometry, we select the gear, and we select this rack mate. Now our pitch diameter, we have a gear with 20 teeth. So I'm going to say the pitch diameter is 20. I know it's asking for the pitch diameter. I'm entering the number of teeth here. And what do you know? I'm going to hit Control Z because that is working a little bit backwards. We'll go back to our constraints, and I'll make sure that I reverse relative rotation. Now we have a gear rack that seems to be meshing properly. So yeah, I felt bad that I couldn't give a more complete answer on how this works, but this should be a pretty good way to enter and make a gear rack for your gear. Hope this helps. Thanks for watching. Please subscribe to the Alibre channel, and we'll see you in the next one.